So we have to now count how many on the left side, how many non-owners and how many owners. Okay, right? So first let's figure out how many observations are there on the left side. So that would be sum of I10 through I16, right? Okay, so that's the number on the left side. Okay, and the I17 to I31, that's the number of observations on the right side node. So the total then is that plus that. All right, so now how many non-owners on the left? Okay, how many non-owners on the left? So we need to count. All right, well, I should say count if, right? Count if first is the range. Okay, and the range we want to count the owners among the records on the left, so which we already did here, but we did it as a proportion, so we need a count now. So that will be count of G10 through G16, right? Okay, so and we want to count how many ones there are in the non-owner column. Okay, and how many owners there are. Again, count if H10 through H16, and how many ones are there in that range, in this range. Okay, so that's for the left side node. Okay. So now that's 7 plus 1, 8, so that's good. All right, so the same thing for the right side. So count if G17 through G31, and we want to count the number of ones there. So that's here on this side. So that's our right side set of records. So how many ones are there in the non-owner column? Okay, and then same thing, count if H17 through H31. So how many ones are there on the right side? So which are owners? Okay. So now we can sum this. That. So this is our observed frequencies. When we make the split, no, for this particular split that we are considering, this will be the matrix of how many owners and how many non-owners on either side, the left side and the right side. Okay. The question now is, how much separation there is? Are these two significantly different on these sides? If it is the same on either side, then that split is not very good. So how independent they are? Okay. So if and for that we need chi-square test. So if they are independent, okay, what the expected values will look like. So we want the variable to be dependent. See, this income should clarify, it should be highly dependent between, there should be high correlation, in other words, between the predictor. Here we're using the predictor as income, right? That income and the target. So target is owner and non-owner. If the predictor separates the target quite well, So that means there is dependent. They are not independent. Okay. So and that's what chi-squared measures. So if chi-squared is really large, so that means there is a lot of separation. So the expected frequencies are if the separation, there is not much of a separation. So the predictor is not doing very well, then this is what the expected frequencies will be. Okay. And the formula for that is for each cell, you multiply the cell belongs to a row and a column, right? So you take the row total multiplied by the column total divided by the entire total. So this will be like that one. Okay. So if you set this up with proper relative frequency, you need to set up only one formula, and then you can copy it. So now you want this row total to always come from the column E, but as you go down, the row should change to 64 to 65, so it should be like that. Then the column total is that, and that should be absolute referenced in this fashion. So the row is fixed, okay, the column changes, and then divided by that one. So that is the entire matrix. So that would be $E, $66. So now this can be copied to the rest of the cells. Okay, so these are our expected frequencies. Okay, so R is 2, C is 2, right? So now the chi-squared, so we need to compute chi-squared. Okay, so here is another set. So the chi-squared formula, okay, is right here. So that's our expected frequency, and then chi-squared statistic is the sum of the difference between the square of the difference between the observed and the expected frequency divided by the expected frequency. So we need to go the observed frequency minus the expected frequency, square that and divide by the expected frequency. Okay, so that will give us the chi-squared value for that cell and then the rest of the cells. Okay, so then the chi-squared statistic is the sum of all that. Okay, so and the degrees of freedom is R minus 1 times C minus 1. Okay. And the p-value is chi-squared distribution to the right side. And the two parameters needed are the chi-squared statistic, comma degrees of freedom. So this will give us the p-value for the split. Okay. Now the log-worth is the negative of the log of p. So here it is, log of p to the base 10. So get negative log of p to the base 10. Okay. So that is the log worth. And the reason why we use log-worth is because p-values are generally, when you have large data set, the p-value will be really small. So it becomes hard to compare really small, two really small numbers. So you convert it into log-worth. So this means, so here we have a p-value which is less than 5%. So you reject the null hypothesis that the two sides are independent. In other words, that the predictor is not doing a good job. So that's your null hypothesis. You're rejecting that. So this is good. But maybe there is another split which is even better. So you look at the log worth and then select the one, so the higher the log worth, the better it is. So the largest log worth is what you would consider. Okay. So this is the third statistic that we can use to evaluate the possible splits. There can be many splits possible, right?